Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, previous sessions already we have discussed about engineering typology subject. We have learned various modules in this engineering typology. So, today I want to discuss about engineering materials questions. So, what are the questions important from engineering materials topic? So, we have covered theory and then some definitions and terminologies, and then important questions. Question bank already discussed in earlier sessions. So in this session, we will see some important engineering materials questions. So first one is that discuss the composition of superalloys and its application. First, need to explain what do you mean by superalloys, and then composition of superalloy and its application. What are the applications of superalloys? Superalloys also known as high performance alloys. So these are a class of materials designed to withstand extreme conditions, including high temperatures, mechanical stress, and corrosion. So they are primarily used in applications where these demanding conditions are prevalent, such as in aerospace, power generation, and chemical processing. So here, superalloys means the performance is very high and also withstand extreme conditions like high temperatures and strength and high resistance to corrosion. So that's why these materials are used in wherever high temperature present and wherever corrosion atmosphere is there. There, these primarily these material, these alloys are used in applications various sectors. They like aerospace and power generation and chemical processing. So that's why these superalloys are also called as high performance alloys. That's the composition of superalloys. Superalloys are generally divided into three main categories based on their primary alloying element, nickel based and cobalt based and iron based. So these alloys are again classified into three. So nickel based superalloys and cobalt based alloys and iron based. In this, the base metal is nickel. In this, base metal is cobalt. Here, iron. So we will see one by one. So nickel based superalloys. So nickel based superalloys, the primary element providing high temperature strength and resistance to oxidation and corrosion. So the primary element, the providing high temperature strength, and these materials resistance to oxidation and corrosion. Next, chromium, enhance oxidation and corrosion resistance. So here nickel material is the base metal, and additionally the alloying element is chromium. So enhance oxidation and corrosion resistance. Cobalt had strength and stability at high temperatures. To improve strength and to improve the stability at high temperatures, the base metal nickel mixed with this cobalt. So molybdenum and tungsten, MO and tungsten. So increase high temperature strength. So aluminum and titanium form gamma prime phase, which provides excellent high temperature strength. Niobium and tantalum and rhenium. So further enhance high temperature capabilities and mechanical strength. So these are the main elements added to this nickel metal to improve, to enhance the properties, to improve the performance of the material. Next, cobalt based superalloys. Cobalt based superalloys, the primary element is known for high temperature strength and wear resistance. Cobalt is the primary element. So known for high temperature strength and it gives wear resistance. The chromium provides oxidation and corrosion resistance. Nickel often added for improved high temperature strength. The tungsten, molybdenum, these two are enhance the strength at elevated temperatures. So wherever high temperature is required, temperature is required, there these cobalt based superalloys are used to enhance the strength. That means able to withstand the high temperatures. So these materials only can withstand. So carbon forms carbides which improve hardness and wear resistance. Next, iron based superalloys. In this, the primary element is iron, often with significant amounts of nickel and chromium. So nickel is adds a high temperature strength and corrosion resistance. So chromium provides oxidation and corrosion resistance. So base metal is iron. So added to the iron, these material nickel and chromium material will add it. So these material provides oxidation and corrosion resistance. So molybdenum or tungsten and vanadium enhance strength and stability at high temperatures. These materials gives high strength and also stability at high temperatures. So does not melt these materials at high elevated temperatures. So that's why, so that these materials are used wherever high temperature is required. So these are classified under iron based superalloys. Now, the applications of superalloys. What are the applications? Already I told you in a previous slide, aerospace sector. In aerospace sector, turbine blades and discs used in jet engines where components must endure high temperatures and mechanical stress. So combustion chamber. So this in aerospace sector, the turbine blades and discs are generally frequent to subjected to high temperature. So that's why these components withstand high temperature and mechanical stresses. You have to use superalloy materials. The combustion chamber so require materials that can withstand extreme heat and pressure. So the combustion chambers. So it requires materials that can withstand extreme heat and pressure. So exhaust systems must resist oxidation and thermal fatigue. So resist oxidation and thermal fatigue. So wherever thermal fatigue is there in the exhaust systems, there must be used these materials, superalloys. In aerospace sector, for jet engines, turbine blades and discs, and combustion chambers and exhaust systems. Power generation, gas turbine and steam turbines and nuclear reactors. Similar to aerospace applications, these turbines operate at high temperatures and pressure. So steam turbines, components such as blades and vanes must withstand high thermal and mechanical loads. In the case of nuclear reactors, structural components and fuel cladding require materials that can resist radiation, damage, and corrosion. So, gas turbines, steam turbines, and nuclear reactors are made with the superalloy material. So, steam turbines mean the components like blades and vanes. So, these turbines or gas turbines or steam turbine nuclear withstand with high thermal stresses and mechanical loads. Chemical processing. So heat exchangers. So operate in corrosive environments and at high temperatures. Pipes and valves used in chemical plants where resistance to corrosion and high strength are essential. So wherever corrosion and high strength is required, there, these materials, superalloys must be used. Next, oil and gas industry, drilling equipment must endure abrasive and corrosive conditions. And pipelines require materials that can withstand high pressures and corrosive environments. So, medical applications, implants and prosthetics means superalloys like cobalt chromium alloys are used for their biocompatibility and mechanical properties. So, what is this biocompatibility? The compatibility with human tissues. So, non-toxic material, non-toxic and able to react or well react with the human tissues. And mechanical properties, strength, hardness, and creep, ductility, malleability, fatigue. These all are mechanical properties. Whenever applied load, the material can withstand from these hardness, withstand highly without breaking, without failure. It can withstand the high temperatures, high loads. These all are comes under mechanical properties. So that's why the super alloys are used in biocompatibility in medical applications and dental implants, surgical instruments require materials that can be easily sterilized and have high wear resistance. Sterilized and high wear resistance. In automotive industry, turbocharger components operate at a high temperature and require materials with excellent thermal fatigue resistance. In automotive industry, turbocharger components operate at high temperature. So wherever the thermal fatigue resistance is required, there these superalloys are used. So that's why used in this turbocharger components. So next question is explain the term ceramic and its composition and list out its various applications. So first term, what is a ceramic material, and what its composition, and list out its various applications. Ceramics are non-metallic, inorganic solids that are typically made from clays and other natural materials through a process of heating and subsequent cooling. So natural materials through a process of heating and subsequent cooling. They have crystalline or partly crystalline structures and are often brittle but hard. So ceramics are non-metallic materials. So properties: high hardness and strength, high melting point, and good thermal and electrical insulation, chemical inertness, brittle and prone to fracture under stress. So that the ceramics, they having the properties, so that's why these materials are inorganic solids that are typically made from the clays and other natural materials. So high hardness and strength, melting point, and good thermal and electrical insulations. Some properties you can enhance by using heat treatment. So brittle and prone to fracture under stress. Next applications: construction, bricks and tiles used in building construction, for walls, roofs, and flooring due to their durability and aesthetic appeal. The cement and concrete. So essential components in construction for making structures and buildings. In construction side, one is important thing is bricks and tiles, and the second one is cement and concrete. Next, household application: tableware, plates, bowls, cups, and other kitchenware made from ceramics due to their hardness and ease of cleaning. Cookware items, baking dishes and cookware are made from heat resistant ceramics. Tableware items, plates and bowls or cups. These are made from these materials, ceramics materials, due to the properties having hardness and also easy of cleaning. Industrial refractories used in furnaces, kilns, and reactors due to their ability to withstand high temperatures. Subabrasives materials like silicon carbide and aluminum oxide are used as abrasives for cutting, grinding, and polishing. So, abrasive materials like silicon carbide and aluminum oxide are used as abrasives for cutting and grinding and polishing. So, medical, dental implants, ceramics like zirconia are used for dental implants due to their biocompatibility and strength. Like zirconia used for dental implants, why? Because the material having the biocompatibility and strength. Bone substitutes used in orthopedic applications for bone repair and replacement. So whenever the replacement is required in a medical application, these materials, ceramics materials used for bone repair and replacement. So electronics applications, capacitors. Ceramic capacitors are used in electronic circuits for their excellent electrical insulation properties. So insulators are used in electrical power lines and other electrical applications due to their high resistance to electricity. The capacitors, ceramic capacitors are used in electronic circuits. So actually, for their excellent electrical insulation properties, these materials are used in ceramic capacitors. So insulators also used in power lines and other electrical applications due to high resistance to electricity. In the aerospace sector, thermal barrier coatings. Ceramics are used to coat engines, components, and protect them from high temperatures. So ceramics are used to coat the engines components. Many engine components are piston, connecting rod, crankshaft, cylinder, and piston rings. These all are engine components. So these components protect from high temperatures. So that's why the ceramics are used as thermal barrier coatings. Structural components. High strength ceramics are used in various structural components of spacecraft and aircraft. High strength ceramics are used in various structural components, spacecraft and aircraft. Art and decoration. So, pottery and sculptures. Ceramics are widely used in art for making decorative items, pottery and sculptures. Next, to explain the composition of polymers and list out its applications in detail. So, in this question, he has asked polymers composition and also list out its applications. Polymers are large molecules composed of repeating structural units. The structural units are called as monomers. Monomers connected by covalent chemical bonds. They can be natural like cellulose and proteins, or synthetic like polyethylene and nylon. Polymers exhibit a wide range of properties and can be engineered to meet specific needs. The properties of polymers are: one is lightweight. So polymers generally have low densities, making them lightweight. Corrosion resistance. They resist corrosion and degradation by chemicals, making them durable in various environments. Next, flexibility. Many polymers are flexible, which uh, which allows them to be molded into different shapes and forms. So that polymers having that much of flexibility, so you can mold to any shape. Thermal and electrical insulation. Polymers often have low thermal and electrical conductivity, making them good insulators. So varied mechanical properties depending on the polymers, they can range from very soft and rubbery to very hard and rigid. So depending on the polymer, they can range from very soft to hard. So that the mechanical properties are vary. Next, applications of polymers in packaging. Plastic bags and wrappers, widely used for packing food and clothing and other consumer goods. Here, bottles and containers. So used for beverages, cleaning products, and other liquids due to their lightweight and durability. So in construction, pipes and fittings, PVC and other polymer pipes are used in plumbing and electrical circuits due to their resistance to corrosion. Insulation materials, polystyrene and polyurethane foams are used for thermal insulation in building. So pipes and fittings like PVC and polymer pipes in construction side. So use polymers for their property of lightweight and durability. Next, electronics, insulating materials, polymers like polyethylene and Teflon are used for insulating wires and cables. Flexible circuits used in flexible electronic devices and variable technology. In automotive sector, body parts and interiors. So here polymers are used to make car bumpers, dashboards, and interior panels due to their lightweight and impact resistance. The fuel systems are polymers like nylon are used in fuel lines and tanks. So in automotive sector, used as a body parts and interiors, and also used as fuel systems. The consumer goods, toys and household items. So many everyday items like toys, kitchenware, and furniture are made from polymers. Sporting goods, polymers are used in equipment like tennis rackets, helmets, and protective gear. So these materials are used in equipment like tennis rackets and helmets, the protective gear. In our agriculture unit, greenhouse films. Polymers like polyethylene are used to create greenhouse coverings. The irrigation systems, polymers are used in deep irrigation tubes and systems. From greenhouse films and irrigation system, the polymers are used. Next question, list out advantage and disadvantage of magnesium alloys. So the magnesium alloys are used in variety of applications due to their unique properties. So now in this question, how to give list out the advantages first and then disadvantages of magnesium alloys. First we will see advantages. Lightweight. The magnesium is the lightest structural metal, making its alloys ideal for applications where weight reduction is crucial, such as in automotive and aerospace industries. So high strength to weight ratio. So the magnesium alloys offer a high strength to weight ratio, providing good mechanical properties while keeping the weight ratio. The excellent machinability. So magnesium alloys are easier to machine compared to many other metals, resulting in lower cost and improved efficiency. So these are the advantages of magnesium alloys, and also used as a damping components. So good damping property. These alloys have good vibration damping capabilities. So it makes them suitable for use in components where noise and vibration reduction are important. So the electromagnetic interference shielding, that is EMI. So the magnesium alloys can be used for EMI shielding, which is beneficial in electronic and communication devices. Next, recyclability. So the magnesium is highly recyclable, which contributes to sustainability and environmental conservation efforts. Sustainability and environmental conservation effort. Biocompatibility. Certain magnesium alloys are biocompatible, making them suitable for biomedical applications such as implants. So already we have discussed in a previous question. Dental implants and orthopedic components. So certain magnesium alloys are biocompatible. So that's why these materials are suitable for medical applications. So disadvantages are also there. So disadvantages are corrosion susceptibility. So the magnesium alloys are prone to corrosion, especially in humid or salty environments. The protective coatings or treatments are often necessary to improve their corrosion resistance. How to improve the corrosion resistance? By applying coatings or treatments. Some heat treatment process are there. So it is all these processes are enhance the properties. So limited high temperature strength. The strength of magnesium alloy tends to decrease at elevated temperatures, limiting their use in high temperature applications. So the magnesium alloys tend to decrease at elevated temperatures. So why? Because you can use these components at elevated temperatures, limiting their use in high temperature applications. But the strength of the magnesium alloys tend to decrease at elevated temperature, does not exist at elevated temperatures. So this is the one disadvantage. Next, cost. Well, the material cost of magnesium can be low. The production and processing cost can be higher compared to some other metals due to the need for specialized handling and equipment. Flammability. So magnesium can be flammable and burns at high temperatures. So which poses a risk during manufacturing and in certain applications. So next, brittleness property. Some magnesium alloys can be brittle and have limited ductility, which can lead to cracking or failure under certain conditions. So these magnesium alloys materials are brittle, so having a limited ductility property. So these materials fail under certain conditions. Anisotropic properties. So magnesium alloys can exhibit anisotropic mechanical properties, meaning their strength and ductility can vary depending on the direction of the load. Next, creep resistance. So the magnesium alloys generally have poor creep resistance, which can be issue in applications involving long-term exposure to stress at high temperatures. So next question is discuss various industrial applications of copper-based alloys. So the copper-based alloys are used in wide range of industrial applications due to their excellent electrical and thermal conductivity properties. And also the copper-based alloys having corrosion resistance and mechanical properties. So that's why these materials are used in industrial applications. The electrical and electronics industry, the applications are electrical wiring and cables, Due to its high electrical conductivity, the copper is used extensively in power generation, transmission, and distribution. Connectors and terminals. The copper alloys like brass are used for connectors, terminals, and switches due to their good conductivity and mechanical strength. The printed circuit boards, PCBs. Copper is used as a conductive layer in PCBs, essential for all electronic devices. So the connectors and terminals, copper alloys like brass are used for connector. Why? Because these material having good conductivity and also mechanical strength. For connectors and terminals, good conductivity property is required. The printed circuit boards, PCBs. So main here the copper is used as a conductive layer. So the PCB is used essential for all the electronic devices. Next, automotive industry. Applications, radiators and heat exchangers. Copper's excellent thermal conductivity makes it ideal for radiators, heat exchangers, and other cooling systems component. Brake systems. So copper alloys are used in brake lines and brake pads due to their strength and corrosion resistance. Similarly, connectors and wiring. The electrical systems of vehicles rely on copper wiring and connectors for reliability and performance. Next, in marine industry, the applications are ship hulls and components. Copper nickel alloys are used for ship hulls, propellers, and other marine components due to their resistance to seawater corrosion. So the heat exchangers and condensers used in marine engines and cooling systems for their anti-fouling properties and thermal efficiency. So construction industry. The applications plumbing. Copper pipes and fittings are standard in plumbing due to their durability and resistance to corrosion. Next, roofing and cladding. The copper and copper alloys are used in roofing and architectural cladding for their aesthetic appeal and a long life. And also used as fasteners and fixtures. So brass and bronze are used for door handles, locks, and other hardware for their strength and corrosion resistance. In aerospace industry, applications in aerospace used as bearings and bushings. Copper alloys are used in aerospace bearings and bushings for their wear resistance and ability to withstand high loads. The electrical systems. Copper wiring and connectors are critical in aerospace electrical systems for reliability and performance. And heat exchangers used in various aerospace cooling systems due to their high thermal conductivity. Then industrial machinery. The applications are bearings and bushings Bronze and brass are widely used in bearings, bushings, and other moving parts for their low friction and wear. Here, in aerospace industry also used bearings and bushings for their wear resistance and ability to withstand high loads. But in this industrial machinery, used in bearings and bushings and other moving parts for their low friction and wear resistance. So gears and worm wheels. Copper alloys are used in gears and worm wheels due to their strength and machinability. The copper alloys are used in gears and worm wheel. These all are used in mechanical engineering, the gears and bearings. So heat exchangers, industrial machinery often relies on copper-based heat exchangers for efficient cooling. Next, coinage. The applications in the material used in these coins, copper nickel alloys, and other copper based alloys are commonly used in coinage due to their durability and resistance to wear. Telecommunications. Cabling. Copper cables are essential in telecommunications infrastructure for their excellent conductivity and reliability. Connectors. Brass connectors are used extensively in telecommunications for their durability and good electrical properties, so that these materials are used as a connectors, having good durability and also good electrical properties. So these are the important questions from engineering materials we have discussed up to now. So in this session, we have seen various industrial applications of copper-based alloys, and then advantage and disadvantages of magnesium alloys, and composition of polymers, and list out its applications in detail. So composition, and then and applications also we have learned, and then the ceramic definition and the composition and various applications, and also we have studied discuss composition of super alloys and its applications. So references I have taken for these questions listed here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.